This is AQA A-Level Chemistry, and it's the Year 12 topic that introduces the key principles of redox, reduction and oxidation. As always, I'm going to recommend that you pause as you go and check your answers so that you can see how you're progressing. So let's start off with the basic principles, defining a redox reaction in terms of either transfer of oxygen or hydrogen. Now, there are some key definitions here, and as it says on here, you need to learn them so you can understand them and, more importantly, go on to apply them. So let's take a look in the first instance at some of the key terms. Have a go and see what you think. Now there's a logic here. The oxidation, we are going to gain oxygen, and reduction, we would therefore lose oxygen. So oxidation, gain oxygen, there's a really obvious link there. And for hydrogen, the reverse is true. So oxidation is loss of hydrogen and reduction is gain of hydrogen. If we take that forward and apply, let's see how you get on with these questions. Okay, so magnesium here has been oxidized because it has gained oxygen. In the second example, the magnesium oxide has been reduced because it's lost oxygen. But actually something else has happened as well. The hydrogen has been oxidized because it's gained hydrogen within the reaction. When we look at the bromine and hydrogen reaction, well, the bromine is gaining hydrogen and therefore it's reduction. And this final question about what's missing, we should really be getting into the habit of adding state symbols to all of the key reactions that we look at. So I've added those in there so that you can see them. Now let's move on, because actually the key term when we talk about redox now is going to be considering oxidation and reduction in the context of loss or gain of electrons. And there's a little mnemonic here to help you. Oil rig, oxidation is loss of electrons, reduction is gain of electrons. And one of the things that we can do is use half equations to actually recognise if something is being oxidised or reduced. Have a read through this worked example and then answer the questions. So we have got here the reaction of magnesium and oxygen. That's reacting to make magnesium and magnesium oxide. We have got then some breaking down of the equation into half equations. So we can see the magnesium has gone from Mg to Mg plus 2, and the oxygen has gone from half O2 to O2 minus. So in C, is the magnesium being oxidized or reduced? Well, the oxidation state has gone up, and you can actually see in part D, where we've balanced that equation, that electrons are being lost. So in C, the magnesium is being oxidized. And in F, the oxygen is gaining electrons. Now, from oil rig, oxidation is loss, reduction is gain of electrons, so the oxygen is being reduced. Now let's look at another example. Titanium reacting with oxygen to make TiO2. Okay, so let's start with the equation. Let's break that equation down into its half equations. Now the Ti has gone to Ti plus 4. Oxygen forms ions with a charge of minus 2. That's how we can work that out. So O2 goes to 2O2 minus. We can build our electrons in. So that becomes Ti goes to Ti plus 4 plus 4E minus. And O2 plus 4E minus goes to 2O2 minus. So the titanium has lost electrons, so it's been oxidized. The oxygen has gained electrons, so it's been reduced. And there are two ways to identify whether a species has been oxidized or reduced. You can look at whether electrons are being gained, that means they're added on the left of the equation, or reduced if they've been lost, if they're added on the right of the equation. But you can also look at the oxidation state itself. If the oxidation state goes up, it's oxidation. If the oxidation state is reduced, it's reduction. And in the next video, we're going to look at a lot more detail at oxidation states. Thank you for listening. Goodbye.